أهلا بكم في قناتي Sat Math 800. Today we are starting with one of the most important geometry on the SAT. It's a circle, the circle and its property. And we will start with circle basics and key properties. This is R is the radius of a circle. This is the arc length S. This is arc of a circle. Of course, we know that the circumference of the circle equal 2 pi r, the area of the circle equal pi r squared. This is central angle, and this is inscribed angle. And of course, we know that central angle equal twice inscribed angle when they subtend the same arc. This is a sector of a circle. It's enclosed by two radii and the arc. Let's talk about central angle and inscribed angle. Central angle. It's an angle, its vertex at the center of the circle, and the two sides of the angle are radius. If the central angle equals 60 degree, then this arc will equal also 60 degree. The sum of the central angle of all the circle equal 360. And the semicircle, what is a semicircle? It's half the circle equal 180 degree. The inscribed angle. The inscribed angle is always half the measure of the arc it intersects. The inscribed angle intersects this arc, so it has half the measure of the intercepted arc. And central angle is equal the measure of the arc. If an inscribed angle is 30 degree, then the arc will be 60 degree. This is some theorems about angle. Inscribed angle that subtend the same arc are congruent. This is an inscribed angle, and this is also inscribed angle. They are subtend the same arc. They are open at the same arc, so they are equal in measure or congruent. If a radius is perpendicular to a chord, this is the radius, it's perpendicular to the chord. This is a chord. What is the chord? It's a straight line from the circumference to the other circumference. And this is the radius. If the radius is perpendicular to the chord, it's bisect the chord. And if it and vice versa, if it is bisect, it will be perpendicular, and this is a radius. If two tangent, what is the tangent? The tangent is a straight line which touches the circle in one point from outside. We have a straight line that touches the circle at one point. If we have two tangents start from the same point, if two tangent segments are drawn from the same external point to a circle, start from external point to the same circle, then those two segments are congruent, equal in length. They are equal in length. The line segment from the center to this point of tangency is perpendicular to the tangent, and this is the radius is perpendicular to the tangent, and this triangle is congruent to this triangle. The two tangents touch from outside, from one point, touch the circle at 2 points. The radius which touch the tangent in the same point of tangency, the radius will be perpendicular, and this is the same. This straight line which we draw from the center to the point of tangency bisect this angle and bisect also this angle. And already we have this radius is equal to this radius, so these two triangles are congruent. Triangle is inscribed by a semicircle is always right angle triangle. This is a triangle is drawn in just the semicircle. So AC, the widest side in the triangle, is the diameter of the circle. If the triangle, one of its side is the diameter of the circle, so the triangle is right angle triangle. This triangle is 90 degree. AC is a diameter, the arc AC is 180. We will take now the area of the sector. We have, of course, to memorize all these definitions. A sector area. We have two kind of measurement to measure the sector area. One of it's by degree and the other with radian. By degree is a degree as we always done and always measure with when we use a protractor and measure the angle. We said this angle is 30 degree. Degree is the standard measure we used to use to measure the angles. So the area, the sector area, when we measure in degree, is theta over 360 times pi r squared. What is theta? Theta is the central angle over 360 by r squared, because it's this area. Memorize it like this. Theta is the angle, the central angle which subtend the sector we want to measure. We want to measure the area of it. So theta over 360 times pi r squared. This is the central angle in degree, and this is the sector area with degree. If we measure with radian, the sector area will be half r squared theta, and we have to be sure that theta is in radian. If you use calculator to calculate this area, we have to be sure that the calculator is defined on the radian. Theta here is in radian. Let's take an example. A circle has a radius of 6 centimeters and a central angle of 2 radians. The numbers of radians when we use radian, we have numbers. It's not common to us. There is no angle equal to in the degree. The degree, we have 10, we have 90, like this, we have 40, 45. We didn't use angle with measure 2 radian. So find the area of the sector. We have the radius is 6 and the angle is 2 radian. The area is, there is half here, half r squared theta. So half times the radius squared times the angle with radian. Sometimes he give you the angle with degree, and you have to convert to radian. You have to use in this formula or this way the radian angle. This become equal 36 centimeters. Another example, a circle has a radius of 8 cm and central angle of 90 degrees. Find the area of the sector. This is the same example. This is with degree and this is with radian. The area here is theta over 360 times by r squared. Theta is 90 over 360, r is 8, so h squared times y equal 16 by centimeter, or approximately 50.27 centimeter squared. Squared because it is area. Now we will take arc length of a circle. This is the arc. The arc is a part of a circumference, and the sector is a part of the area of the circle. This arc also subtended by an angle theta is a central angle. So the arc we denoted by S equal theta over 360. This is the arc, the length of the arc. So theta over 360 times 2 by r. What is it? This is a circumference. This is a circumference. Let's see here the area theta over 360 times this is the area by r squared in case of the angle in degree, and the arc in the length of arc in radian is equal r theta, is equal r theta. The area is half r squared theta. Let's take two examples. If the circle has a radius r equal 5, central angle theta equal 72, S equals 72 over 360 times 2 by times 5, the radius. So S equal 2 by, and of course this is unit length, centimeter, meter, whatever. If the radius equals 10 centimeter and the central angle is 1.2, I said before that the radian gives numbers. It's not common for us. We know the angle 72, but we didn't see before the angle 1.2. This is the angles in radian. What is the arc length? So S equal r theta. So we will multiply 10 times 1.2 equal 12 centimeter. Now we will make a review on equation of a circle. The equation of a circle is x minus h, the quantity squared, plus y minus k, the quantity squared, equal r squared, where h and k is the order pair of the center, and r is the radius. Example, a circle fontaines is located in a park, and its center at the origin 0 and 0. A bench is placed 8 meters away from the center, along the edge of the fountain. What is the equation of the fountain edges? It's a circle. The fountain is in the center. We want to make an edge which placed 8 meters away from the center. So the radius will be 8 meters away from the center. The r is 8 and the center is 0 and 0. We will substitute in this equation. The center is 0 and 0, radius equal 8, h minus x minus h squared plus y minus k squared equal r squared. So we will find the equation directly. This is another example. Circle A is given by the equation x minus 4 squared plus y plus 3 squared equal 29. Circle A is shifted up 5 units. The circle shifted up 5 units and shifted left by 6 units. Then its radius is doubled. This is 3 steps was happened after the circle was in this case. After the circle was like this in this equation, first 3 steps happened. It's shifted up by 5 units, shifted left by 6 units, and the radius doubled. What is the new equation of a circle? This is the circle. Okay, its center was 4 and -3, and its radius was root 29. If shifted up 5 and then lifted left by 6, so shifted up, it will be shifted up, so the y coordinates will affect. Shifted up by 5, so the y coordinate +5. The original center is 4 and -3. So shifted up by 5, it will affect the y coordinate. It will become -3 + 5, and shifted 6 unit for left. Of course, the left is -4. We will make it 4 - 6. So the center, the new center, is -2 and 2. And the radius of the circle is doubled. So the radius is doubled. Yes, it's doubled. It's not squared. It's doubled. Doubled. It becomes twice the first radius. So it becomes 2 root 29. We will substitute in this equation and find h now is -2, k is 2, and we will square this because r squared, this is r squared, and find the equation of the circle. This is a circle. Point D is the center of the circle. The measure of angle BDC, ADC is 70 degree. This angle is 70 degree. What is the angle? What is the value of x? The angle CDA is a central angle. So the angle CBA is inscribed angle. This inscribed angle is half the central angle. This is 70 degree. So this is will be, all the angle will be 35 degree. We will draw BD, connect B with D. BD become a radius. This is a radius, and BC and BA are radius. So this BDC, the triangle BCD and BDA are isosceles triangle, because this is radius and this is radius. And this BD bisect the angle B. It was 350. So BDBA becomes 17.5. All CBA was 35. DB bisect this angle. So DBA becomes 17.5. And this is isosceles triangle. So X is 17.5 also. That's all for our today's lesson. Hope you enjoy watching this video. Don't forget to like and subscribe.